Hello, Traverse City students. Really sorry I couldn't make it last night. Darn Mother Nature and the snow. If it's any consolation, I'm sure it was probably safer that you folks didn't travel out in it either. I saw you got whacked just as bad as we did. So because we couldn't do it together in class, I wanted to make sure we covered everything. So I've put together chapter 5 and 11 for you. And there are some bonus questions in here. So do pay attention. Hopefully you are watching this. First of all, we want to define the term capacity. Capacity is ability to hold, receive, store, produce, accommodate. It's what you could possibly do. Like the most that you could make out of your factory with a given amount of equipment and the amount of time and people. The capacity could be a theater, the most that the theater could hold, the most people without it being overly crowded and a danger. So it's like the max level, okay? In business, the amount of output that a system is capable of achieving over a specific period of time is the best way to define capacity. So capacity management needs to consider both inputs, all the raw materials, all the people, time, and everything going into it, and the outputs. Strategic capacity planning is determining the overall level of capacity-intensive resources that best supports what the company's long-range competitive strategy is. That would include facilities, equipment, labor force size, and much more. Utilities, depends what level of capacity you go to figure. Multi-factor would take in absolutely everything, including rent, taxes, and so forth. How is the capacity utilization rate? What is it, rather, and how is it calculated? Well, capacity utilization rate is a measure of how close a firm is producing to its best operating level. So you have what's called a design capacity, which means, in theory, given all the perfect situations and scenarios, the facility should be able to produce X amount of product in X amount of time. However, in the real world, it doesn't happen that way. There are a lot of variables that can cause you to not be able to produce on a consistent basis the full design capacity. So that becomes your capacity utilization rate. And the formula for that is the capacity used divided by the best operating level, or the design capacity. So what's the difference between economies of scale and diseconomies of scale? Well, economies of scale are the idea that as a planet gets larger and the volume increases, the average cost per unit tends to drop. I just realized that said a planet. Excuse me, I'm chuckling at that. The idea that as a plant, a facility gets larger and volume increases, the average cost per unit tends to drop. Diseconomies of scale is at some point the facility or the plant becomes too large and the average cost per unit starts to increase. Okay? So, let's look at capacity focus. Capacity focus is the idea that a production facility works best when it is concentrated on a limited set of production objectives. The flexibility of capacity is that ability to rapidly increase or decrease your product levels, or the ability to shift from one product focus to another product focused, or from one service to another. So you might go from a product focus to a customer focus. Instead of being so intent on making the perfect product for your customer, switching over to customer focus, which is actually hearing what your customer wants and not what you can produce. So this flexibility comes from the plant, processes, and workers, or from the strategy that's used of the capacity for your organization. So therein lies your first bonus question. What is customer focus? I just explained it to you. It's looking at what the customer wants. and satisfying and exceeding those needs from the customer instead of a product focused. All right. Next, let's look at you have the same chart in your book, by the way. Flexible plans. They have the ability to quickly adapt to change, and they have almost zero changeover time. Flexible process is simple, easy setup equipment, and they can change from one thing to the other, manufacturing this and changing the line over to manufacturing that. The real key to all of it is flexible workers' ability to switch from one kind of task to another quickly. And the only way you're going to do this, bonus question number 2, is by making sure that you cross-train your people. In Japan, the idea of the Toyota production system is that you train everybody in every job in the facility. That way, every worker becomes fully aware of how to do anything in the process to completely. One worker could build the entire product all by themselves. So there's your bonus question. Explain why flexible workers are flexible. Cross-training, okay? All right, so some considerations for changing capacity. Trying to keep the system balanced. Avoid bottlenecks, or at least minimize bottlenecks. Sometimes the cost of upgrading is out of hand if you do it too frequently. The more you change, the more it can cost you. So you have to really think through your changes and your upgrades to get the best bang for the buck. You don't want to do it too frequently, and at the same time, not only for the cost, but you don't want to confuse your people, right? There are some external sources of capacity. You could outsource, or you could share it with another company, which would be a close rival, which you might consider a business partner instead of a competitor. And you could decrease capacity by temporary reductions or permanent reductions. Okay, there's lots of ways of doing it. Thing is to make sure that you're matching up so that you're not producing too much and having a bunch of backup inventory, or that you're not producing enough to meet demand, and now you have to work overtime. That doesn't work out good either. All right, so determining your requirements, you want to use forecasting to predict your sales for individual products, not just you as a company, but your products, because one product may sell a lot more or a lot more frequently than the other products. So you have to figure them on an individual basis, okay? Calculate your labor and equipment requirements to meet those forecasts for those products, and then project your labor and equipment availability over the planning horizon. So in your example in the book, there was example 5.1, determining capacity requirements, in which case we looked at the Stewart Company, who makes 2 kinds of salad dressing, Paul's and Newman's. Each is available in bottles and single-serve bags. So the question was, what are the capacity and labor requirements for the next 5 years? And so if you look at it, they projected that in year 1 they're going to do 60 bottles and 100 plastic bags of Paul's, and 75 bottles and 200 bags of Newman's. Okay, the plastic bags, are probably going to restaurants and so forth like that. So they project it over the next 5 years, and then they look at their capacity and what they're able to produce, figure out the labor requirements, figure out the machine requirements, so on and so forth, and then determine the capacity requirements. Now, anytime you see the Excel in your textbook, it means there is the capability to pull up a template or Excel worksheet to help you figure through problems. So when you have something in an assignment, there's a good possibility. Sorry for the interruption. There's a good possibility there's an Excel worksheet or something in Learn Smart to help you not only learn how to do it, but maybe need it or utilize for part of a PowerPoint presentation in class. So something to consider. Now let's look at what is a decision tree and what is it used for. It's a pictorial diagram or schematic model of the sequence of steps in a problem, including the conditions and considering what the consequences are of each step. Decision trees help everyone analyze and understand the problem and therefore try to identify the best solution or alternative. Now, there are some key questions you need to ask first. Number one, what are you providing to your customer, and how will you meet that criteria? Marketing. Is there a demand for it? How large is the market? Do we even know? If we don't know, we need to investigate. You have to have some idea of what kind of demand there's going to be for your product. Otherwise, you have no idea how much to produce. So you have to figure out the demand profile. How much can be created? Can we meet the demand? Operations, they want to know, can we do it? What is the manufacturability? Do we have the capability? Do we have the ability to service it? Quality, they want to know what level of quality is appropriate. What is our customers' expectations? What's our competition doing? What's their quality like? Finance and HR, two really big issues there. Finance are the beekeepers, the gatekeepers. They're like, can we afford to do it and sell it at this price? So they have to be the ones to assess all the costs, all the labor, everything that goes into making this product or providing a service, and then determining if it's feasible to sell at a certain price. HR, they have to be worried about the liability and ethical issues. Can we be sued? Is it good for the environment? Things like that. And IT, their big job is, what can we do to help out? So that becomes their main focus. What kind of systems do you need? What can we provide you to help you make those decisions and perform the task easier? So the decision tree, first of all, you include all your possible alternatives and states of nature, and you should include doing nothing. You enter the payoffs at the branch, and you determine which value gives you the best bang for the buck, and then you prune the tree of the branches that don't provide you with a good expected monetary value. So we're going to look at an example here. First of all, should we purchase CAD, or should we hire and train more engineers? Or should we just do nothing and just go on the way we're going? So you have to look at the possibility of high and low sales. Something to figure out. All right, if we have a lot of money coming in, what would be the payoff? And if we don't have a lot of money coming in and sales are kind of bad, what would be the payoff? You have to do the same thing on both choices. The same dollar value, or excuse me, the probability value. And they have to, both of these have to add up to 1, by the way. So 0.4 and 0.6 has to add up to a total of 1. And it has to be the same in both so that you're comparing apples with apples equally. Okay? So next, we take a look at, all right, if we have high sales, we're going to have $2,500,000. But if we're going to have low sales, we're only going to have $800,000. Our manufacturing costs at high sales, producing a lot of product, would be $1 million. At low sales, it'd only be costing us $320,000. The cost of CAD would be the same either way. So we do the math and we find out that high sales, we'd have $1 million net. Low sales, we'd lose $20,000. And then we're going to do the same thing down here and below. Now, how you figure the expected monetary value is, you take your 0.4 and multiply it by the gain or loss, and you add the 0.6 times the gain or loss, and that altogether gives you expected monetary value for this branch of the tree. So in this case, this would be, we would gain $388,000. Okay, now when we do the other one, we would gain $365,000. So which is going to give us the best gain? Obviously the 388. So we eliminate the ones that we don't want, and we choose this choice there. You also have the example in the book that you can follow along really easy. Shows you how to figure it all out. So if you follow that, go with the example, do the practice one on LearnSmart in your textbook, because you can do practice problems, you should be able to follow it through and come up with the proper answers, just as we showed you, which is the best choice based on the expected monetary value, which is the EMV. Remember that, EMV, expected monetary value. That's the gain or loss you would get from each decision. And then you're going to find that you're going to be creating a decision tree in your next presentation. All right, so now let's look at planning service capacity. A little bit different than manufacturing, yes? In the manufacturing world, goods can be stored for use later. So you can produce it, put it on the shelf, you can always sell it later. Service doesn't work that way. Capacity's got to be available when the customer wants it, so it can't be stored. Goods can be shipped to other locations in the manufacturing world, but in the service world, it has to be available where the customer is coming to, and that's what's called the demand point. So there is a big difference between the two. So the relationship between service capacity utilization and service quality is critical. Utilization is measured by the portion of time servers that are busy. Optimum levels of utilization are context specific. Low rates are appropriate when the degree of uncertainty or demand is high and or the stakes are high, like emergency rooms, fire departments, and so forth. Higher rates are possible for predictable services and those without extensive customer contact, like commuter trains or postal sorting of the mail. The demand is pretty well constant. All right, so for your next presentation, we are going to be doing it over chapters 5, 11, and 4. Okay, so we're going to do chapter 11 next. And if you have any questions, you need to shoot me an email right away. So we're going to switch over to chapter 11 now. And here we are now, chapter 11, process analysis. All right. So here, first of all, we have to figure out what is a process. Process is any part of an organization that takes inputs and transforms it into outputs. I don't care if you're service, manufacturing, or a combination of both. You have some kind of input coming in and some kind of final output going out. Satisfied customer or manufactured finished good, whatever. The cycle time is the average successive time between completions of successive units, meaning that the time it takes at each station to produce one item from the time it gets the input to the time it makes the output. Utilization is a ratio of the time that a resource is actually activated relative to the time that it's available for use. Now, we've touched on flowcharting a little bit, but now we're going to talk about proper process flowcharting. So it's using the right symbols and making a diagram to represent the major elements of a process. Basic elements can include tasks, operations, flows of material or customer movement, decision points in any area where there's storage or something waiting in line in a queue. So if you looked at the example in your book, you'd see the process flowchart for a slot machine. Okay? All right. Two major types of processes, single stage and multi-stage process, meaning more than one step in the process to attain the objective, finish the product, provide the service, whatever. All right. A buffer is a storage area between stages where the output of a stage is placed prior to being used in a downstream stage. Blocking occurs when the activities in a stage must stop because there's no place to put them. Starving is that activity in a stage where it has to stop because there's no work, nothing done or nothing available. And a bottleneck is a constraint. A constraint. A bottleneck is a constraint. Next bonus question. If you looked at a bottle, it's all big and round, and then it comes down to the end where the liquid doesn't come out as fast because you want it to pour slowly. That's a constraint. That's a bottleneck. That means it hinders or lessens the ability for something to produce. In a bottle of liquid, that's what you want. You don't want it all to come out pouring so quickly. However, in a manufacturing process, a bottleneck or constraint is something that affects your production and keeps it from producing as quickly as everything else in the process. There is in manufacturing and in, I guess it works in the service world too, a complete study of how to remove bottlenecks. It is called, bonus question, Theory of Constraints. You can learn this and actually get certified in being a constraint remover. All right. Okay, multi-stage process with buffer kind of looks like this. A stage 1, a buffer, slowdown point, stage 2. And again, what was a buffer? It was a storage area between stages, so it's like where your work in process goes until stage 2 is ready to take it on and do what it has to do to it. All right. Serial flow process is a single path for all stages of production. Parallel process is an alternative path where 2 or more machines are used to increase the capacity of one station and therefore, in a lot of cases, remove a constraint or bottleneck. Logistics process is the movement of things such as people, materials, or finished goods. So most companies typically have a logistics department that gets raw materials coming in and finished goods getting out, right? Make to order, again, as a reminder, we talked about this before. Make to order is only making something after an order has been received. So once a customer orders something, you start producing it. Both your work in process and finished goods inventory are kept to a minimum. And again, make to stock is based on a forecast or historical data saying, so far we have always sold this much every year, therefore we will build this much to meet that demand. Customer orders are served from a targeted stocking level. So measuring your process performance in your book are all those formulas on how to figure the flow time, cycle time, efficiency, productivity, and utilization. All those are necessary in business to see how well you are doing. Okay? Now, production process mapping and Little's Law. The total average value of inventory is the sum of the value of raw materials, work in process, and finished goods inventory. Inventory turns is how many times are you turning over your inventory, typically figured out a year. And so how you do that is you take the cost of goods sold divided by the average inventory value. Your days of supply would be the inverse of inventory turns scale to days. So it's the inverse or the reciprocal divided into 1. Little's Law basically is the statement that there is a long-term relationship among inventory, throughput, and flow time. Hence the formula is inventory equals throughput rate times flow time. Look at the example again in your book. I'm not going to go over it here, but this gives you a good idea of how this works. And you can see that this facility total was 8,300 batteries. So therefore, their inventory throughput was 40 days. Okay, every 40 days they turn over inventory. Work measurement techniques. This is an important section. What is a work measurement? Well, it's a process measurement where you try to decide how long it takes to do a particular segment of a job or how long the worker should be taking to complete his task. Why should you use it? Well, it's very important. You have to schedule work and allocate capacity. You also want to motivate and measure work performance by this. You have to evaluate how well they're doing, and you provide benchmarks not only for the same process but similar processes in your facility. So it gives you guidelines to figure out how long it should take to do something. What are the direct methods? Well, you could do time study or work sampling, and you could do the indirect methods, which are predetermined motion time data system or elemental data. So one of those 5 ways is the best way to figure out your work measurement. I'm going to tell you that time studies is probably the best way to do it. Predetermined could sometimes be clouded by other factors. Historical data, machines change, technology changes. If you're going to use historical data, you have to be able to adjust depending on circumstances. Don't be hard numbered about it. All right. So doing a time study, you want to define the task to be studied, divide the task into precise steps or elements, figure out how many times to measure the task, time, and record elemental times and reading of performance. Now, let's go back here to number 3 for a moment. Here's the thing. When you look to decide how many times to measure the task, it should also be a matter of who. That's what really counts. And I say who because you want somebody who's very experienced. You also want somebody who's just starting the job. So you can't expect somebody just starting the job to perform as well as somebody who's been doing it for a while. So you have to kind of, get an average number here. So you pick a brand new or slower worker, a very experienced worker, and a person somewhere in the middle. Take a timing from each one, add them up, divide, then you get the best average time for the task. All right, so in doing a time study, you take the average observed time. How you get that is by the sums of the times recorded to perform each step divided by the number of observations. So if you took a good, a slow, and a mid, add their times up, then you divide by 3, and that would give you your average observed time. To determine the performance rating and normal time, that would be the average observed time times some sort of performance rating factor. Okay, like a great production worker would be a 10. A so-so production worker might be a 0.7, and a new or slower worker might be a 0.5 for a while. So that means you would be looking at some different times based on the person's capability and ability to perform. So you add the normal times for each element to develop the total normal time for the entire task, and you compute the standard time. Standard time would be the total normal time divided by 1 minus an allowance factor. Okay, what's an allowance factor? Well, you have to give some personal time allowance. 4 to 7% of on average of a person's total daytime use is for going to the restroom, getting a drink at the water fountain, whatever they have to do for some personal thing, like maybe they got a cold, so they got to go over and blow their nose, for example. All right. The delay allowance would be anything that would cause that station to be delayed, like mechanical breakdown, stopping to lube something, stopping to reload the machine, anything that would be a delay for a known or good reason. All right. And then you have to look at fatigue allowance. Fatigue allowance, what is that? Well, let's explain that. And this is your last bonus question. What is fatigue allowance? Well, when your people come into work in the morning, they are performing probably their best because they're wide awake, they're ready to go. And as the day goes on, typically right after lunch, there's a slight delay or a hindrance to their production, because it's a fact that once you eat and rest for a bit, you tend to get comfortable and you don't come out of the gate as fast as you went in. But by the end of the day, people are generally a little bit more tired. They've been working all day long, and so they're going to be fatigued. If you're working people overtime, extra time, like 10 or 12 hours for the day, yes, they're going to be fatigued. And then even more so, if you're working people on a regular basis in overtime, they're going to have a higher fatigue level. So the fatigue allowance has to be commensurate with the time of the day that they're working and how many hours a day you're working them. 6-7 days a week, the fatigue allowance is Okay, so work sampling time studies, real simple. You take a pie chart, like this clock is here, and you look at how much of their day is spent doing these various activities. So, 20% of the day is this person's sales in person, face to face. 12% of his day is on the telephone, and so on, right on down the line. Okay. In the production world, manufacturing, did I not provide that? Yes, I did. It would be like 3% of their time is spent on startup, and 10% might be break and lunch, and downtime and cleanup. So they're only productive 67% of the day. So it's looking at the work job in different ways, whether it's a service job or a production facility. You're going to take this little sample of time and break it up into how much of their day is spent doing what. So you take a preliminary sample to obtain the estimates of parameter values, compute the sample size required, set out a schedule to take random observations at appropriate times, and it's a good idea to measure in the morning and then later in the afternoon too, so you get kind of a well-rounded out picture. Observe and record their worker activities, and in tune you're going to develop a complete idea on how workers spend their day. Are they very productive, or so forth and so on. All right, so one last thing here. Let's look at the example for a current layout for bread making. Notice there's raw material there waiting. Then there's a baking time and work in progress. Well, because this cycle time is 1 hour to do 100 loaves, this one is 3/4 of an hour to do 100 loaves. So they're actually waiting because it takes them less time to pack than it does for them to bake. So this needs to build ahead. Otherwise, these folks are standing around for 15 minutes a day waiting for the product to come to them. So what you have to look at is, what can we do to even this flow out? So if you put in another parallel line, then you're having one come out every 30 minutes. One every 30 minutes. If you start them and stagger them. So every 30 minutes there's going to be 100 loaves ready. These folks are able to do it in 3/4 of an hour. So they're going to have a little bit of work in progress ahead, build up, but it's better than them saying they're doing nothing. All right? All right, so ways to reduce your process flow time: perform the activities in parallel, change the sequence of events or balance them out a little bit so they're all moving about the same time, reduce or eliminate any interruptions. So don't forget, what you should have been doing was, let's see, this homework is all, the one that you're going to worry about right now is Chapter 4 homework, which is due the 28th. And we'll be doing your next PowerPoint in 2 weeks from yesterday because we couldn't get together. So I'm going to take a look at what the best way is, and I think I may just evaluate your PowerPoint based on what I see and give you a score from there. Okay, now, bonus questions. Oh, again, your next PowerPoint is over chapters 5, 11, and 4. All right, so bonus questions. Here they come. All right, so again, if you have any questions, make sure you shoot me an email. Now, the bonus questions, as promised. You have only until Saturday night to get these answers to me. So by Saturday night, I should have these bonus questions if you want your bonus points. They're worth 5 points a question. You can get up to 25 bonus points from me. Number 1, what did I mean by customer focus? Explain it. I said so and described it early in the lecture. Why is cross-training important? What culture 100% cross-trains their employees, and why? Question number 3, what is EMV and where is it used? Number 4, I stated when doing a time study, use a very experienced, a mid-experienced, and a low-experienced person. Also, vary the times a day for time measurements. Why? And the last question, what is a fatigue allowance? What is it used for? Those are it. Send those to me by Saturday to frank@ferrisfa.com for your bonus points for the week. Have a great week. Sorry we couldn't get together. I'll be seeing you soon.